Welcome back to the stream, folks. The rack was in power down mode for a bit. The shop was so hot around here. So, yeah, all the video gear booting back up, getting ready for a new stream. This one might not be really long, but yeah, we have a few things to do. Maybe first I could just join you on this lovely sofa object with some coffee. So a lot of you know that I have a cat. He's an amazing little guy. He's right here under the coffee table. His name's Tuco. I've also been taking care of these two cats that aren't mine, but are still really amazing because they're cats, obviously. And so there's this little black one, Luna, and this big old fuzzy boy, Cloud. And things have been alright. The little black cat, Luna, she's actually currently, you might see her just behind the leg of that stool. And then Tuco's under this table. So the two of them have just been having this stalemate, just staring each other down. And, oh, hey, Tuc, stop that. Hey. And then stuff like that happens every once in a while, and I have to break them up. Hey, boy. Maybe distract him a bit. So that's been a little stressful. And Cloud, the other dude, he has a broken leg, and he's in surgery right now. I dropped him off at like 7:30, which is 2 hours ago here. Hey, Tuc, I know you want to hurt her, or at least, like, be mean. I don't know. They've both been kind of mean. So my strategy has been to try to distract them, but I'm just looking for a bolt. Hey, Tuc. Maybe you should look over this way. Anyway, so Cloud is in surgery right now, and I don't know, just waiting to hear back from the vet. You drop him off, and then he's, like, I don't know how long the actual surgery takes, but then he's got a little bit of hospitalization there to recover. But they will be keeping me notified via telephone, I guess. And so in the meantime, we've got some cats, we've got some code, we've got some winches. I've been writing a lot of code for these winches recently, which has been mostly, for me, an exercise in learning Rust, which has been nice, and some in learning React. Hey, Tuc, I think he's really eyeing Luna. I need to get him a bolt. Hey, buddy. Hey, Tuc. Yeah, there he goes. So yeah, some of this, when he gets, you know, too much pent-up hunting energy. And so Cloud's in surgery. Yeah, so I've been cat-sitting these guys for about a month already. It's been maybe like 3 weeks, and it was, you know, always kind of a slightly uncertain kind of long-term cat-sitting deal, because I'm taking care of them for somebody who's, like, overseas and looking for housing in this area, so it's been difficult to find, and she doesn't have money, and it's, you know, and she needed someone to take care of these cats because otherwise they were going to end up at a shelter. They ended up with a housemate who, like, couldn't take care of them suddenly, and so anyway, it's just been stressful. They Tuco and Luna have this standoff going, and now Cloud's in surgery, and I'm worried about him. So I was reviewing security camera footage around here too to see if I could figure out exactly when he broke his leg, and I've narrowed it down to sometime between, I don't know, it's been a couple weeks now, but like, yeah, it was like a Wednesday morning and a Thursday morning, and he was just like playing around the previous day, and then something happened to him, like where I didn't see him and where none of the cameras saw him, and then I noticed him hanging out under the bathroom in the or under the tub in the bathroom, having a not great time, and it looked like it was a sprain, but you know, we let him rest up like it was a sprain, and then took him into the vet, and the vet was like, well, we should get an x-ray just in case. It might be hairline fracture. It's probably just a weird sprain. And then it was this like kind of gnarly break, and so it had already started to heal wrong, and now he's in surgery getting it kind of straightened. Hey Tuco, that's a microphone. And then I got home from taking Cloud to the vet, and something was like super irritating my eye. Like I think I'm slightly allergic to cats. Tuco's pretty hypoallergenic, so he doesn't really bother me much, but I think I got some kind of cloud dander in my eye or something, and it was super puffy. So it's been hard to get a break around here. But despite that, the winches, been making progress on those. I feel like everyone is tired of winches now, but I've got one that's pretty much done. I think, you know, it's at one of those points where I could keep fussing with it. There are some things that aren't amazing about it. It's still a little bit creaky as it winds up. I took it entirely apart the other day and put in a new vertical roller and glued in some bearings that might have been wobbling. Oh, Tuco. Hey, Tuke. Hey, Tuke, where's your bolt? So that helped it substantially. It's a lot less creaky than it was, but it's not perfect. And it's probably going to be more trouble than it's worth to get it completely non-creaky quiet at this point, just since like it might be the kind of thing that involves redesigning more of these parts that I would like to just be done with. So I think it's a good time to call this a revision and move on. So at this point, you know, I can assemble the rest of the winches. I've got most of the parts printed out for that, and put some work into actually documenting this one. I should make a video about just the winch bot. I keep thinking, well, that video would feel really incomplete without some footage of several winch bots cooperating to move something around, because that's what they're really for. But, you know, it's a question of, like, what do I want to predicate that work on? Should I just try to get a video out now? And maybe that's the thing to do, and I can save the multi-winch scenario for a cliffhanger, 'cause that's kind of how it feels anyway. Ah. Cloud dander. Yeah. Yeah, finding housing in this area is super hard. I was just strolling over to chat and trying to catch up briefly, but hey Tuke. You want to play with the bolt, not Luna, right? Housing is super hard. It's also super hard when you don't have money. It's also super hard when you have pets. And it's just like there are a bunch of situations like, you know, like disabilities, for example, that make housing difficult to find. And it just all adds up to a really difficult situation. So I don't even know, like, I think the original plan was that Luna and Cloud are going to stay in the Bay Area. I think the new plan might be that they're actually headed to LA with their cat mom eventually. But, you know, it's still kind of uncertain. Either way, I'm taking care of them for at least a few more weeks, I think. And it's been, I'm ready to be done with it, but it's also fine, and like, they're lovable little guys. It's just been a handful keeping them and Tuco. I mean, at least with Luna, it's been kind of a handful, and Cloud and Tuco, it was kind of harder to tell. Like, it seemed like they were a little bit skittish around each other, and sometimes Cloud was a little bit afraid of Tuco, but it also seemed like they were playing together, and you know, so it's kind of hard for me to judge their mood, especially since I don't know Cloud very well. Was that a bad throw? Am I just doing a bunch of bad throws here? I don't get that. Maybe I'm just going to sit here and drink coffee. Well, yeah, so the winch is interesting. I'm trying to figure out how to actually present it in the next video, and because like it's a weird thing to have to build. Like part of why it feels super weird that it's been taking this long to actually get the winch working is that just a one-dimensional robot that just pulls a rope doesn't seem like it should be that complicated. But there was a lot to consider when I wanted it to be something that could be like safe to operate around kids, or not kids, but like, you know, humans that don't know any better, and pets, and you know, so I wanted it to have a lot of sensors. So the force sensor turned out to be really useful. I wasn't really sure how accurate that was going to end up being, but so far, like, I mean, I don't know about long-term drift in the calibration, but so far the force sensor's been great. Like, it's been enough to really feel comfortable just like kind of running it to both ends of the travel that I have set up here, and when the cord goes slack, it stops. When it, you know, hits the top pulley, and, you know, before my pulley is attached to comes crashing down, it just stops really nice and gently. And so that's been nice. Hey Tuka, are you gonna behave yourself? All right, well, so over on this side of the shop, we've got one cat, one winch. Let's see if I can just remotely operate this winch from over here super lazily. Oh yeah, there we go. I'm just using the app on my phone. And so I still have probably a lot more PID loop tuning in my future. I'm still getting used to what the different, the different parameter ranges are really useful for. And I just recently turned the derivative gain way down because it was causing some oscillation. And now it's doing better, except it's a little slow to start, and there's a bit of overshoot. So the integral gain could use some tuning, but it, all the fail-safe features still work after redesigning the control loop to work based on position instead of velocity. And you might also see the lighting going. So there's like an ambient color right now that's just blue to indicate that I have that winch in like manual operation mode. Grabbing the Xbox controller because it has some buttons for this. And so it's also got, this is like its automatic mode, which isn't programmed right now, so it's always going to be stalled. And then there's like halt mode, like it's explicitly not going to move. So if I put it back in manual mode, then you can see if I kind of get it up to speed, those little waves follow the motion. Anyway, so I'll set up the DSLR and we can take a closer look with an actual camera in a sec, but that's pretty much what I've been doing, is writing code for the winches, taking apart the winch, putting the winch back together, debugging the winch. And so let's see, if I'm just like raising this up and I grab onto this, you can see it turn red. And so actually there are two things it's going through, which are a little easier to see if I drop it down onto the floor. There's like kind of a soft failure mode and then like an I am stuck mode. So if I just slowly lower this, and there we go. So it's just solid red. So now it's at a point where if I push the control stick down, it refuses to move any further in that direction. But I can just raise the control stick and it goes up just fine. But if I go to the ground a little faster and kind of get it under its minimum set point. I guess that was still not fast enough. Oh, there it is. That flashing doesn't look quite like I expected it to. I think there might be a bug where it's going in and out of this halt mode. Anyway, or maybe I just have the lighting slightly different than I expected. Anyway, that's like the flashing where it's it thinks it's stuck and it needs a human to come help. And Luna's been pretty interested in this. Anyway, let's see what the web interface shows, because that's got a lot more detail than just staring at the wide-angle view here. I just saw Ellen in chat say, "How long before a cat clambers onto that spool as it goes up?" Yeah, no, it totally has. I mean, that's... Oh, you mean the one, that spool. So the cats seem less interested in the spool that's moving around than they do in the actual bot. So, and I think if the cat was grabbing the spool, it would just stall, and like the stall limit is set to something like 3.5 kilograms, and so the cats are much heavier than that. But Luna especially is interested by the winch itself. I don't know, she seems pretty thrilled by the whole situation. I did have a test I was doing, I think this was last night, and I had some cord hanging down from the winch. I was testing it with like much less cord on the spool to see, you know, to test some things that would be different under that circumstance. And I was getting some weird stalls, and then, you know, didn't notice until after I looked over there because it was dark that Luna was under there actually grabbing the cord. See, she's kind of into that. All right. I think we need the inception over here. So this is actually running on the streaming machine. So here's the OBS setup, and got this little window here that runs the bot controller and gives me a QR code I can use to actually open it up elsewhere. So let's switch to the elsewhere. I guess I can run this on my phone. It would actually be nice to have it on the computer here, though. I just need to SSH or like mount that file system so that I can get the URL on here. Because, I mean, mobile's nice, but the portrait aspect ratio doesn't work super well for the stream I'm doing right now. Okay. Let's mount that file system. Alright, Tuco Flyer. We don't need this camera right now, do we? Whoops. Alright, that'll do. Maybe let's move that over a slight bit. Pardon my real-time rearrangement here. Yeah, QR codes, I agree. Kind of annoying for marketing, but useful for pairing devices. So here, I just have it dumping like a Unicode QR code into this text file. So it shows this in the terminal when it starts, but you can also just access this file however you want to access files, and then either snap a photo of it with your mobile or paste it into a desktop browser. Yeah, I agree with Luna in the photo. It's very servo AF here. Oops. Okay, let's use some of that responsive design here. It's not actually that responsive. Okay, so we got a few different tabs here. We've been hanging out before in this interface a bit. Most of that stuff is in these Winch tabs here. Wireless signal for my mouse is not the best right now. So we've got the actual bots. You can see the data coming back from the sensors. So here's the force sensor, the filtered force sensor. There's a bunch of sub options here for doing, like, we did this calibration procedure on an earlier stream where we actually came up with the calibration constants that it needs for the two sensors. You can actually use this to drive the winch around from the web interface. So you can see there's some lag there. A lot of that is intentional. There's a acceleration limit that gets applied at the manual control stage. That used to be in the Winch firmware, but I decided to move it to the central controller because that really wants to happen before the stage in this whole algorithm where you split up the control to the many winches, because you want to ramp up the acceleration of the whole robot, not just of a single winch. So that's now done in the Rust software. So the like the gamepad and the web interface just send like joystick events. But then the Rust server, when it's in manual control mode, it uses those events to ramp up this manual control velocity, which then moves a target position. And then the actual winch, its firmware gets that target position, and then the PID loop tries to track that position relative to where it thinks it is. And so these positions aren't like absolute position in the room. It's just like cumulatively how much distance has the sensor reported. So it's not going to be really accurate over long periods of time because of, you know, cord stretching and a little bit of, you know, if it slips at all, that'll accumulate. But it should be plenty enough for, you know, kind of short-term stuff like tracking a particular move. And it's all designed assuming that those numbers can eventually roll over. So it's all like integer, you know, 32-bit arithmetic that's modulo 32 bits. So yeah, so this is working basically the same as this controller, which is a little bit more convenient to use sometimes if you're actually in the room. And then if you go over to the PID tab, so this here you can see the position error, which should, yeah, it starts to build up as we start to move the winch, and then the winch follows. And you can also see it just kind of snap to 0 like that. So that time I just moved. Well, let me go through this in a little more detail. So it's near the floor now. I'm going to move it up and then stop, and then you can watch the response. So I'm just going to go, like, I'm going to make a square wave with the joystick. So I'm going to go full strength up, so it ramps, and I'm going to let go. So you can see the response where it ramps up, and then it actually overshot a little bit, so it tried to back up, but then it got close enough. There's like a dead zone where if the position is close enough, then it treats it like 0. So then the proportional gain goes immediately to 0. The integral starts falling off because there's a decay factor there too, and then the actual PWM command goes to 0. So if you go all the way down here, you can actually see the PWM that's being calculated for the motor in real time. And that bit of overshoot and correction. And then this is the same value. So this is the value that we're sending to the motor, basically. This gets converted into clock cycles and then sent directly to the PWM hardware. This is the same number, but broken up into the pieces that are coming from the proportional, integrated, and derivative gains. James says that'll make it impossible to make very small moves, won't it? Yes, which is probably fine. It'll just mean that I mean, I don't think I want it to necessarily always be, like, I don't think that I want the motor to always be on. I think if you're tracking something and it's moving and it's like keeping within the frame, I guess what I'm trying to say is I want there to be several layers of hysteresis so the motors don't have to always be powered on. And so some of that will be like this object is still in frame, I don't need to move the camera, and some of it will be, you know, the winch position is still close enough, and these will layer, and I think that's going to be fine, but that might be one reason to tweak the dead zone, and so that's one of the parameters that you can change in this UI here. So, and like this is all stuff that I've tuned a little bit just to make sure that it all works, but like it'll need tuning for the particular situation the winch is in once the whole thing is actually assembled. And it might even need tuning a little bit differently depending on how much weight is on the winch, which is something that we might have to factor in later. But that's something where, like, the firmware might want some changes so that it's possible to change the integral gain without it changing the contribution of the integral gain immediately, like just a different way of storing that. But for the most part, I could do any kind of gain changing that I want to do on the PC side rather than on the firmware side. So yeah, now we've actually got values underneath pretty much every slider here, or every graph here. So you can also see these little hitches there. So like obviously right there, it just got stuck momentarily. Well, not stuck, but the sensor failed to register any motion. So that's actually, I think, what happens when the cord slips off of one of the other windings on the spool, which I don't have a great solution for right now. And that's one of those problems that I could solve, but it would be a really big undertaking, and so I think I'm just going to save it for the next revision. And I think it'll be fine for the moment. But that's what these little spikes are, is when it actually skips. At least that's what most of them are, I think. Hey Tuco, I hear you. So yeah, we've got a PID loop with a lot of tuning parameters. There's the deadband. So this is when it's like close enough and it stops. Here it's oscillating in and out of deadband. Why is it doing that? I mean, the deadband doesn't have hysteresis, which is fine. But it looks like something, maybe, is that causing the position sensor to move? The swinging? It is. Okay, that's interesting. We're getting enough. So that position sensor is very sensitive. It's like a 300 count per revolution optical sensor. That's a nice oscillator. Yeah, and the filter takes care of it. It's not a big deal. I'm just surprised that the sensor was accurate, or sensitive enough to pick that up. So you can actually see the calibration factors over here. Yeah, so these are in SI units per hardware unit. So kilograms force per A to D count is this. So that's milligrams, right? No, microgram. No, that's milligrams. So one A to D count, I mean, obviously there's a lot of noise, so this is fluctuating around by a lot more than one A to D count, but that's a pretty small number. But then this distance number, right? So this is in meters. So that's 33 micrometers, I think. So, you know, obviously not going to be accurate to that number because the wheel that like the capstan that the cord runs over is not, it's like 3D printed and slightly wobbly, so obviously not. But it does mean that there's a lot of resolution there, so we can detect very small motions, so which is kind of fun. So yeah, a lot of software going on. There's this kind of low-level view. There's all this motion control stuff under the winch. I think we've been through the interesting parts of that. I put all the the editable stuff under these buttons because usually I don't want to edit, and it was nice to not accidentally have that ability. Wow, that was a nice little browser time hiccup. What happened there? Anyway, I also have done a little bit of work on lighting here. So this is going to be a little harder to demo during the day, but if I turn the overall brightness, you can kind of see that there's some lighting going on in that winch. You might be able to see the kind of wave pattern move as I raise and lower it. So the UI here looks super rough, I know, but I wanted to at least have the very basic ability to save different lighting configurations for like daytime and nighttime and special events. And this is the ugliest color picker, but so for example, if I go to halt mode, it's red now, and it's actually this color. So I can just move this around and see what looks good on the LEDs. I can make it pink when it's halted for some reason, but maybe I don't actually want that. And I can just go back to that, that's fine. But yeah, the wavy light is nice. There's a lot of parameters for that, so if I put it back in manual mode. So, in fact, I can make the background color a little lower, and then we can see the animation a bit better. Yeah, so it's a sine wave that moves along, and it's actually two sine waves. There's one for the position that it's sensing and one for the position we're commanding. And I'm not really sure if there's a reason to use both for the animation. I think right now I might only be using one of them, but it seemed like it was a nice thing to have. I guess I have a really subtle color for the commanded position. That's why sometimes you see them kind of break up into two waves. That's what's going on. Completely disableable by just setting one of the colors to all zeros, but so it's just a sine wave that I offset above the x-axis and then run through a like a floating point exponent to make it kind of peaky. And so that's what this exponent is. And then that whole thing ended up looking kind of abrupt, like as the waves just appeared and disappeared at the beginning and the end of the winch. So then I windowed that whole thing by multiplying it with a cosine function. Oh, sorry. Oh yeah, thanks for answering the question. Definitely was asking what the Tuco flyer is written in. Yeah, the actual backend that's running this website is a Rust daemon. And then the firmware is in C. There's a lot of JavaScript, for the front end clearly. And I might have to do some C++ code for an OBS plugin. But yeah, it's been nice writing Rust where I can. This has been my project to really actually learn Rust, and so I've been using it for that too. So yeah, I've got this window function where if I just turn this really far up so that the window doesn't really have much of an effect. Yeah, now you can kind of see the pulses kind of starting and stopping. There's still a window happening, so it's not even going to be as abrupt as if I completely didn't have that. And then if I turn this really far down, then it'll just appear in the very middle, which also looks kind of abrupt because there isn't enough like LED space to actually show the fade in and fade out completely. So yeah, you can twiddle with these and then reload the parameters that actually work. Oh yeah, so James asks, plugging this into OBS sounds like it could be useful. What's the plan for that like? Yeah, so that's how the streaming for this is going to work. So I mean, I'm using OBS for streaming this right now, but I'm also planning on using OBS to stream the Tuco flyer, which will have its own streaming channel on Let's Robot or maybe Twitch. And so with that, I mean, that'll actually probably be a simulcast where OBS is doing like a high-quality kind of view-only stream on Twitch with chat, and then there'd be more of a real-time interaction thing on Let's Robot. But my plan was to try to do that with OBS using a plugin to do the computer vision. So OBS would actually handle, doing overlays and compressing the video and sending it to Nginx or Twitch or whatever. And And then I could just write a plugin that handles the video as it goes through that pipeline and does whatever computer vision I want. And that plugin would then probably communicate with the Rust daemon over WebSockets using the same protocol that the website here is using. Maybe it gets something special, but it can probably just use the same thing. I mean, this is basically, once you've authenticated to this, it's kind of an interface to the robot's internal message bus, effectively. So, like, this is just the same state that the control loop is dealing with in the Rust program. Yeah, you can see it going in and out of dead zone mode just from that wobble back and forth. That's funny. Or maybe that's the browser struggling to keep up when it stops like that. Hard to tell. Yeah, I don't know what these periodic gaps in the data are. I'm assuming that's something on the browser side, and not the and not happening in the actual daemon, but it's a little hard to tell. Let's try the mobile version. Luna is doing some climbing, and Tuco is super curious about it all. I think I had a different layout that was a little bit better for vertical. No? Really? Oh, here it is. Kind of. This is just kind of in the way now. Okay. Let's get Tuco back on the camera. Oh yeah, yeah, there's some good questions. So Ear asks, could the firmware be done in Rust as well? It definitely could. I just didn't want to open that can of worms right at this moment, since it was really, really easy to do in C. But yeah, the main reason I didn't want to do it right away is because I didn't want to create a firmware that would be really difficult to compile with the current versions of everything in 6 months, since it seems like everything is changing pretty quickly in the Rust embedded space. So, given that the firmware was pretty simple and I just wanted to write it and leave it alone, it didn't seem like that was quite the right choice. But I'm really enjoying Rust for the desktop side, and I'll find an excuse to use Rust for firmware really soon, I'm sure. So, it's definitely a thing. I just wasn't sure it was the right thing for this project. And then that's another interesting suggestion from Ear, who says piping WS into PV, which is pipe viewer, which also lets you slow down data in pipes to see if the data rate drops. So I experimented with that when I was working on the kind of data rate congestion control kind of stuff for the WebSocket server. And one problem I ran into is that it doesn't handle that super well. What I'm actually more interested in is controlling the rate between the two WebSocket servers, and the effect of piping it into PV means that you just kind of arbitrarily end up blocking the WS process on its standard out when the output pipe fills, which WS doesn't necessarily handle super well. And the way I'm handling end-to-end congestion control right now is to use the WebSocket protocol's pings. And so doing something actually in between the two WebSocket server and client on the network level is actually going to be much better. And so for that, I just ended up testing it on my phone a lot because the Wi-Fi here is bad. So here's my phone, opening up the bot controller on here. So it scans that pretty easily. And then this will work, but it's actually a little bit faster if you open it in Safari, because something about the performance of the WebKit JavaScript engine. And I'm not seeing the same gaps in the data here. Oh, there's one. I mean, if that gap was in the actual... So I'm just realizing I don't have a great way of making sure that the Rust server is not experiencing interruptions yet. My plan for that is to have a watchdog thread in there, because it's got a bunch of threads. There's one thread that's basically doing the main control loop, and then a few other auxiliary threads that are handling kind of message passing to and from different clients and servers. Whoa. And my plan there is to have the sort of main thread be the watchdog that ensures that the controller thread is pumping out messages consistently. And that isn't written yet. But the Winch itself, its firmware actually has a watchdog timer like that. And so if we miss more than like 2 frames, which are 1/250th of a second, then the Winch will just stop. And so that hasn't been happening, so I think we're fine. I think that was just a browser hiccup we were seeing. On mobile especially, there are some hiccups early on when it's like reallocating resources or JIT compiling code, or like all the little things that it'll do to try to get the web page just up really quickly, but then go back and actually like reallocate things or replace replace functions with compiled versions. Like that can cause little kind of transient glitches in the performance. So, you know, this basically works on mobile. Anyway, so the Winch is not perfectly silent, but I think otherwise I'm pretty happy with its operation. And the gears, the 3D printed gears have been working out great. Like, I was super worried that the gear train was going to be the loud part in this project, but the gears that I made with a PLA hub and then an exterior, like the teeth made it of Semiflex, those have been great. I put a little bit of Teflon lubrication on them, and they've just been amazing. So I put way too much lube on them at first, and they were kind of sticky with lube and making noise, but then I wiped off all the extra lube, and then they started working really great. And of course, this thing is fun. Let's get a closer view of the mechanism now that I've yammered about this and shown the website so much. Yeah, that's a good question. So I'm going to get a closer view of the mechanism. Garrett's asking where the clicking sound comes from when the motor is loading. And most of that is coming from the cord slipping on the pile of cord on the spool. I think a little bit might still be coming from weight shifting around on the big vertical roller. But let's take a look. I might have to put the camera on the tripod. Hey, Tuco. This is my not really sufficient for video tripod, but it's the best one I got right now. I had a film crew in here recently because I was helping out with a video for it was like basically a product promo, but for like a thing that I actually like. And they had a really nice tripod and a really nice camera. camera is on the list of things to upgrade one of these days. DSLR is not optimal for video, but it certainly... I like the lens on this thing. It's definitely the best thing at collecting light that I have in the shop. Okay. Oh, that's interesting. Nicholas suggests an interesting test could be using only one soft gear in each pair. I was thinking about that, but I thought that it was important in gears for the two gears to be made of materials with kind of the same hardness. So I thought that would just be a recipe for really quick wear if I did it that way. But that's an interesting suggestion. I'm curious why you think that would help. Well, maybe I should take off the left side. I can get a better view in there. I'd like to get a view through the side if I can, just before taking this off. Running myself out of cord here for my camera. Let's see if that looks like anything. Yeah, so some of those are coming from the cord slipping, but some of them definitely aren't. Let's take off that side panel. Maybe get a camera on toque. A little bit of cat. Such blurry. That is not at all servo AF. Oh, that shot's a keeper. Delicate focus pull skill. Kinda underexposed. Oh, you're such a good cat, Tuco. Alright, so that needs, I'm gonna have to like hang that on a clamp or something, because the cables I need to unplug to get the LEDs free are on the other side. that one not quite fit. Kind of fits. Cool. This just needs to hang on just a little bit. Okay. That's super effective. I just can't resist doing some focus pulls while Tuco's sitting there. So I think I know that vertical roller is still part of the problem. It's not quite cylindrical, and you'll notice it usually doesn't even want to spin when I'm lowering because it settles on a flat spot. But then when I'm winching it up, it spins and slightly wobbles. There I am hitting the upper force limit. Well, I'll get the camera in closer now that the cat's gone. Oh, Lynn wishes Cloud the best. That's great. For anybody tuning in late, one of the cats I am cat sitting right now, Cloud, is in surgery today, getting his leg fixed. He broke his leg and wasn't diagnosed as a break until it had already healed or started to heal in the wrong position. And so he's got orthopedic surgery today. So yeah, definitely some of the creaking is still coming from that vertical roller. I had designed a version of that previously that was a bit thinner, and so this was my attempt to redesign it, make it as thick as I could to try to make it easier to be circular enough, and I printed it on my more accurate 3D printer since I was having trouble with the tall cylindrical objects on my Delta printer not actually being that cylindrical. Yeah, so James says that good spoolers have a piece that moves the cord from side to side. Totally. That's the thing that I'll probably want on the next revision of this. I was trying to see if I could get away without it on this revision, and I think I did, but just barely. Like, it's not pretty, but it works. And so, yeah. Another idea that I want to try, actually a previous version of this spool had a kind of like a scoop-shaped profile to kind of push the cord toward the center so that it isn't always falling off of itself as much. And I ended up going to a more cylindrical profile, mostly to make the spool a little bit easier to make. And I think it might be worth trying the kind of scoop-shaped profile again, but I don't really think it's worth like redoing the spool again. So, like I was saying earlier, there's a bunch of stuff I could fix about this, but I think it's time to call this a revision and not just endlessly nitpick the design, because I think it's plenty good enough right now. But, you know, we want to understand the problem so that we know what to do next time. So yeah, that vertical roller isn't as cylindrical as it could be, and the winding could be a lot nicer. but I don't think any of this is a problem. You can see it kind of overshoot the velocity at first when it's accelerating, and then that's just the paid loop integrative gain being too high, I think. But I think it's just funny that I was so worried about the gears being loud, and it's like the gears, you can barely hear them. Like I can hear the metal gears in the main gearbox, but I can't hear anything from the, you know, and at least anything that I can tell is coming from these herringbone gears. Let's get a slightly different camera angle. Can we get any further over? My focus plane does not go quite that close. You might also notice the rough surface on that vertical roller. One of the things I tried was to mount it in the bearings and then spin it on my belt sander, which helped a little bit, but it's still not quite cylindrical. Oh, I just noticed but you can also see this whole contraption makes the cord want to roll a little bit, and then as it's rolling, well, not going down, but going up, the cord rolls and then kind of scoots left across that roller, the one in front. See that? I had not noticed that until just now. I'm running out of space, so let's run it down. And then here you can see that that vertical roller isn't really helping much going down. There it is going slack. The sensor stops it before it tangles. Oh yeah, there's a good question in chat. What kind of material are the gears made of? So that red plastic on the interior is regular PLA, and the white plastic on the exterior is Semiflex, which is a blend of PLA and thermoplastic urethane. That time I got it under the stall limit. I have it set so that there's a minimum limit where if it's under that, it also thinks maybe it might be tangled and it asks for some help. I think it might be set a little bit too high still. Let's get another camera angle. I think I'm going to write a script for this one because there's just too much I want to say. I'm probably just going to script it and do a voiceover. And there's just way, like, I've had a lot of luck before in making videos where I just kind of comb through archives and get all the dialogue I need from the video I've already got, but that actually takes a long time to do, believe it or not. And so it might actually save a lot of time to do a voiceover for this video. Well, maybe I should open up the other side too. The measurement mechanism's a little more interesting from that side, but honestly, maybe I just want to get it from the top. Because it is pretty good from the top. Oh. Alright, tripod, do your best. Zuko left me a bolt right over here where I'm stepping on it. Oh, it is overexposed now. Let's fix that. Yeah, and then I can see the cord going around the other rollers. I should really get a shot with the other side open now. So from the left to the right, we have a few more rollers. There's a big flat one, which just kind of rounds that corner. And then those two short horizontal ones on top of the bot. The first one serves to keep the cord down on that flat roller, and then the second one actually tensions it just a little against the capstan, which is the big kind of bumpy pulley that the encoder is attached to. And then that pulley on the very end, that one's also not amazing. I think that one really needs to be fairly smooth, and that the sizes are such that it's easy for the cord to get stuck in its housing right now, but also not really worth redesigning at the moment. That pulley attaches to the very end of a load cell, and so that's actually not attached to the frame directly, but the other side of the load cell, so kind of under where the capstan for the encoder is, that's actually bolted down to the frame right next to the load-bearing M8 threaded rod. The lighting has just a slight bit of interpolation when it changes states. Let's take off the other side. All right. Ah, good little winchy. Yeah, naked winch action. It's not actually super hot, thankfully. I should take some actual temperature measurements, but so far the most heat has been coming out of the back of the power supply. And I've been taking some AC line power measurements with just the kilowatt. And so it idles at around 6 watts. And the most I've seen it draw from that reader, from that measurement, like looking at the kilowatt screen, which is somewhat low pass filtered, is like 80 watts. I think, well actually I've got the kilowatt connected right now. What does this say? Okay. Can I put a camera on this? I'm gonna bring another camera over here and we can give you a view of the power meter in real time. under. Oh man, this DSLR cable makes me nervous, especially with such a light tripod. Great. All right, we got some watts. And this is close to the maximum load I designed this for. It's 1.5 kilograms. I mean, I've tested it with like 3 kilograms and it's been fine, but this is what I was kind of targeting with the flyer. So you can see it, you know, it takes some serious energy to load this, or to lift this thing still. Oh yeah, good question from James about what the actual load limit is. So yeah, a lot of this was going based on that 5 kilogram sensor. I think the other main limit is just the amount of power I can deliver to the motor. I don't think the plastic is getting close to, I mean, it might start creaking more, but I don't think it's close to its actual load limit, since most of the actual load is being borne by those threaded rods in this configuration. So yeah, I don't know actually what the breaking point's going to be. I don't really feel like destructively testing one of these since they seem to be strong enough for my needs at the moment, but it might be worth destructively testing if I have some spare parts in the near future. Let's see if I can get any more interesting views of this while I've got it open. The motor is pretty beefy already. It's, well, so right now the configuration I've got is 24 volts, and the power supply can deliver 6.5 amps, which is the main current limitation that I have. The driver is rated for a lot more than that. In practice, I usually see this motor draw about 4 amps peak, but I haven't measured its stall current properly, since I think that might break the gearbox. I'll lower this tripod maybe. Well, while I've got the tripod up, let's do an above shot, but I think really I want to lower this tripod. It's got, hey train. It's kind of got little bat wings on the side. Oh yeah, this would be a good time to demonstrate one of the safety features, which is what happens if it loses signal from one of the sensors. It was actually a little harder to demonstrate losing signal from the force sensor. Although actually I think I can just pull one of those wires. I think I've got it on jumpers where I can disconnect them. Let me first just demonstrate stalling the position sensor. So here it is, going down. If I stall this sensor, so I'm still holding the control stick down, but it's got basically a watchdog timer, so that if it's putting out more than a certain amount of power into the motor and seeing less than a certain amount of motion for a certain amount of time, then it triggers an error condition which causes it to stop trying to move for a little while and then reset all of its internal state. It only takes a little bit of stalling for it to trigger that. It's very sensitive. And yeah, so can I show you the force sensor doing the same thing. Okay, first of all, which wire is the force sensor? I think this one should do it. So I'm lowering. Yeah, and it stops. And now it starts. So that'll just end up giving it, you know, completely out of range or incomplete force measurements, and so that'll trigger another timer. You know, all the stuff you'd want this to have, like, and of course if you yank out the network cable it stops. So James says push up or down on the force sensor should work fine. Yeah, they're just slightly different failure modes for not getting a signal versus getting an out-of-range signal. And so I did have to add code and specifically test for the case where, you know, either the data line or the clock line is disconnected, because those even both give you slightly different failure modes in this protocol. It's like kind of a weird SPI protocol. You know, you can do it with an SPI controller, but it's a little bit weird. Like, you have to give the device exactly 27 clock cycles, if I remember right, that kind of thing. Yeah, what other shots do we need to get? Maybe something lower. Oh, Tuco, Tuke, leave her alone, honey. Tuke. Tuco. Tuco, stop that, honey. Tuke. Hey, Tuke. Oh, jeez. Hey, Tuco. Oh, this cat. Maybe. Oh geez, there's still like a whole cup of coffee here. Clearly I should just drink it and throw the volt for Tuco. Oh, interesting. So James is also using the same sensor I'm using, the HX711, and they're having an issue where the code just freezes up completely if it goes disconnected. And there's a gain. I wasn't, and then, oh, geez. I think this is fine. Anyway, let's get maybe some more video. Yeah, so anyway, the HX711. So I don't know what library you're using. I guess it might depend on what you're doing. Mine is interrupt driven. It's something I wrote for this project, and it waits on the device to. Hey Tuco, come here, little guy. It waits on the device to say that it's ready. So we're effectively using the sample rate timer on the HX711. So it'll run at 10 samples per second or 80 samples per second. And it has, and I forget the details of the protocol, but it has something where it signals that it's ready by pulling the line low or high. And then you send out some clock pulses and read the bits. So I think I'm going to hang out with Tuco a bit because he is getting really rambunctious, and maybe I could use a coffee break anyway. Hey, Tuke. So in my case, the receiver was interrupt driven, so it doesn't hang my main loop or anything, but it just means I stop getting samples. And so I needed to add a watchdog timer specifically for that, so that if I don't get samples from the HX711, but the control loop is still making progress, then like know that those readings are out of date and you shouldn't trust them and you should probably just stop. And so that's what it does. Hey, Tuco. Now I'm trying to find a bolt for him. Tuco, do we have any in your bolt reserve? There's usually some bolts under the stove. They end up down there. I think Tuco knows this, and he actually got his claw a little bit stuck on the side of the stove sheet metal the other day, which was not good. I was lifting the stove while I had a friend push on Tuco's butt to try to get him closer to the stove so he wouldn't just yank on his finger. Hey, Tuke, here's a bolt. Tuco, is that not sufficient? He is a weird little creature. Oh. Yeah, I've been trying to, like, safety design is a big thing that I was trying to actually do with this. Like, I mean, it was a lot of work to make a fully enclosed winch. I'm still a little bit worried about that front pulley being a bit of a pinch point, but I think if I mount it like where I'm planning on mounting it, that won't be especially accessible anyway. But yeah, the force sensor turns out to help a lot with safety, but it doesn't help for everything because, like, for example, imagine if your PID loop is just completely tuned wrong and just blows up. You want a way to detect that separately from the input to the PID loop. So, you know, so that's why there's a separate thing that looks at the input and looks at the state of the motor controller and turns off the motor if the motor has been running, even though we aren't commanding it to go anywhere, things like that. So there's a bunch of layers of different things that try to all prevent humans and animals and robots from getting hurt. Hey, Tuke, is this one you want? See if I can get any more photos of this thing. I'm a little disappointed in these emergency stop buttons. I saw these on Big Clive's channel and on eBay, and I thought, well, these are really cheap, and got some, and they seem to be all right. They're actually designed, it's like it's sort of like the fake GST connectors that I got recently. It's like they copied a design that someone had put a lot of thought into it, but then didn't make it out of great materials. So, It's not actually switching the 120 volts, it's switching the 24 volts. Not even the 24 volts going into the motor, because that would involve some high current arcs if things were going wrong. But it's switching the control circuitry on and off, which isn't optimal, but has been plenty sufficient for this so far. This has been the side of the winch that I most often look at, because that's where the microcontroller is. That's pretty satisfying, I have to say. Yeah. And so that just stops the single winch, which right now doesn't have much of an effect on the central controller. It just stops getting data. But as soon as I start trying to coordinate multiple winches, I'll really want that watchdog on the central controller, so that if that isn't getting data from all the winches, then you want to stop all the winches. So that then you can press emergency stop on anything, or even just unplug the network switch that the robot is running on, and it'll all stop. There's also a halt button on the controller, which just puts it into halt mode. And so there's some differences between just like letting the PID loop settle, which is, so if I'm holding the control stick down and then just like let off the deadman switch, then the PID loop just settles. But if I'm running it up, if I'm running it either direction and then actually halt mode, then I'll just immediately send the, I'll just immediately start sending different packets to the controller that just tell it, like, no matter what, just stop moving. It isn't actually quite as abrupt as that. Those packets will include no position target, or like an identical position target to the current position, and all the PID gains will be set to 0. And so that'll start kind of coasting briefly, but then one of the firmware safety features where if it's not being commanded to move and it is moving, like that'll kick in and then just like zero out the PID gains in like a quarter second or so. Or zero out like the integrator. So this is what we got so far. It is not silent, but I think it's quiet enough and safe enough. Oops. Maybe needs to be mounted slightly nicer if I'm actually going to run it up against the pulley all the time. Oh yeah. It might help if I actually tightened this thumb screw. Let's try that. Let's run it up against the top again. There we go. That's how it's supposed to work. You can see it not pulling itself apart. It flexes a little bit as it gets up to the... What is that set to? I think it's set to like 4 kilograms. I think the phone will probably tell me. Let's go back to the view where we can actually see this. No, not that. Baywatch. Yeah, that's about 3 kilograms right now. And that's the limit that it hits. So if I'm just holding up steady on the control stick, then you can see it hits the limit, goes into kind of a refractory period where it doesn't want to run the motor. It lets all the PIDs go back to 0 and then tries again. But that's all done in the firmware for the most part. Oh. There is some code on the central controller that resets its velocity and position target when it detects a reset on the remote control loop, but I didn't want to trust the local control loop for all of that, you know. Or, you know, the PC side control loop. I guess local in this case should really mean the thing that's on the same side of the network as the motor. Yeah, now it's below the minimum limit, so it won't actually move until I get it. Yeah, and now it'll move. Yeah. Maybe since we were talking about it, I should pull up the HX711 driver really quick. I think I should probably end this stream in a sec. Like I said, this probably wasn't going to be a super long stream, but it's been nice to show the progress on the robot so far and have a bit of a distraction while I'm waiting for Cloud to get through his surgery. So, actually... So all the code for this project is in GitHub, in the Tuco Flyer organization, which seems to need some CSS. Are we having a problem with GitHub today? Maybe we're having a problem with GitHub today. Okay. So, wow, this is jarring. So we want bot firmware. Is this a problem with my browser? Doesn't look like it. Yeah, force hx711.c. So yeah, we're using the SPI peripheral, and then there's a state machine. Everything's driven by this SPI interrupt. So yeah, wait for data low. So here's how the sensor actually signals to us that it's ready. It'll hold the data pin high, and then we're actually waiting for that edge. So I think we also have an edge sensor interrupt. How does that work? Yeah, GPIO int clear, int enable. So yeah, we're using the GPIO interrupt to notice when the sensor is ready, and then the SPI interrupt to do a couple of transfers. And so we actually have to transfer it in two parts. The SPI register on this processor can hold 16 bits, but we actually need to send one of these, so I guess we're sending 25 bits, because that's how you select the gain. It's pretty weird, but small driver. Oh yeah, I guess other people are having the same problem with GitHub's not doing its CSS today. Cool. Maybe I'll get a shot of these empty shells while I have them open too. I'm mostly just doing some photography of these for the next video that I'll put out, which I still haven't written a script for, but I'm sure I'll need some of these shots, so might as well get them while the light's good, you know? That looks kind of nice. I might do one of these with the lights out of focus too. Maybe another close-up shot of the microcontroller over where the network lights are. Not that they... You'd think the network lights would be interesting, but of course the activity light is just constantly on, so it doesn't really blink. It is right next to the gears, though. Huh. Oh. Ha! Well, a safety feature just totally found an actual problem that I was oblivious to. Let me show you what happened. I think this happened while I was running it past its lower tension limit. The cord wrapped around the outside of these two pulleys, and now it's... it looks like it's hitting stall mode, where it gives the motor some power, doesn't see any motion, and then cuts the power. So if I try to run it up, see that? But if I run it the other direction, then that's a problem, because I can just run it that direction as much as it wants because the force sensor is basically jammed. So that's not great, but I don't know of a super good solution for that. If I... Phew. It's a little weird because it wants to react to any change in the position sensor. Like if I turn this slowly, then it wants to counteract that just like a servo motor would. Now it's fine. Yeah, I mean, that's a good test, because like if that was just willing to just dump all the power into the motor, then it would just overheat or break something. Oh, good question from Ear, who says, I really love the programming streams. Do you envision more of those in the future? Well, definitely. Yeah, no, I do a lot of programming. I've been doing a lot of it off stream because, you know, sometimes I'm in the mood to just kind of like be more in my head, but I love hearing the feedback, and you know, if you think the programming streams are good, I'll try to do more of that on stream, because you know, I like sharing that, and it's good to know that not everybody finds it boring. I think I'm just going to get a few more angles of this and then call this a stream and go back to worrying about my cat and well, worrying about not my cat, but worrying about a cat that's in my care at least, and doing other work that isn't quite as interesting. I don't know, I have one of those things where I kind of need to start a new project for something kind of unrelated, but I've been procrastinating it, but I think I should actually get it started today, so there might be more to talk about that soon, but right now it's just kind of a pile of procrastination in my head, so I need to get past that. Oh yeah. I'll try to do another sort of just brief like showing off the Winch stream when it's dark, because I think the lighting is kind of nice. But yeah, mostly I just need to put more of these together, and I'd also appreciate, you know, if you just really want to see me like cleaning up 3D prints and gluing things together, then I can do plenty of that on stream. Otherwise, I'll have a lot of it to do off stream if that's just boring for everyone. So yeah, let me know what you want to see. I've got robots to build, I've got code to write. I definitely have some hacking to do, and that's definitely going to be on stream. So I need to do a little more planning for that, but that should be happening pretty soon. This is slightly tricky to put on because I have all these wires to wrangle, but this goes on 1/2. Mostly it's a matter of keeping these wires from poking out in front and actually going between the case and the front of the innards. I'm really glad for all the stuff I didn't try to attach to the outer shell, because having stuff attached to the outer shell is annoying. The LEDs are kind of annoying, but totally worthwhile. Also optional if you're building one of these, you totally don't have to put LEDs on it. But to the left side. And then these can just kind of hang out under the power supply. Oh man, I'm really happy with this shell. I feel like the shell was one of the riskier parts of the design because it was just so much printing to do before I could even test it at all. But I'm pretty happy with it. Looks like I lost a couple of screws while I had this open. Oh, here's one. One thing that could be nicer is a way to capture the screws when you open it, because the screws are always falling out. Oh, I guess I really should show this thing unmounted from the wall, because that is a pretty nice look, and I should get that while the lighting is good and consistent with what I've been getting. So let's do that after I put this one last screw in. So for that, I'll just run the winch in manual mode until I've got all the cord inside it, and then unplug it and take it off the wall. We can show you what that looks like. Alright, so that's back together. Let's reset this. Oh yeah. Ear says they work from home and having the long programming stream humming along feels like being in a small office. Yeah, I like that feeling too. I enjoy hanging out with other people's streams for the same reason. Oh, shout out to Hedgeberg on Twitch if you don't follow them. They've been streaming some Nintendo Switch reversing. That's been nice. I think she's doing another stream this Sunday, but maybe I'm getting the schedule wrong, so you should check. It feels like it can maybe use another screw like at the bottom, but it's holding together just fine. I can show you a little more of what I'm talking about. Let's actually undo that knot. Alright, and so you see the winch turn red. It will refuse to reel this back in without any tension, but if I put some tension on it, then it'll be fine. I'm gonna get a slightly different camera angle. I know the sound on this particular headset can be a little bit harsh, but it is nice to be able to wander around the shop sometimes without having to shout into the microphone. Alright, he's got his little hair tuft. Slurp it up just a little bit. Alright, so then we unplug power, unplug network, loosen the thumb screw, and then take it all the rest of the way after rotating it. And so that's what the back looks like. It's got its IP address, power supply, motor, and Ethernet. Nice little grabby screw. Happy little winch. I think that's why it's not fitting quite as well, is because these... I think I shouldn't have overlapped that wire with the power supply truss there. I should have kept it on one side or the other. I can fix that next time I have it open. It seems to still fit alright though. So yeah, got a solid winchy thing over here. All right. Yeah. So, one of my favorite parts about the shell design is that they stack. Yep, so, yeah, 1 down, 3 to go. These still need some cleanup, like most of the parts, but, yeah, I think I might, settle in for some of that soon, after taking care of some of the work I've been procrastinating. I think that's about it for today's stream. Oh, looks like the 3D printer has some more power supply mounting arms for us. But yeah, maybe I'll go in there and get another print started, since I do have the headset. I don't even have to stop talking. I can just go there. This is one of those parts where I thought I had printed everything I needed, but then I started actually trying to like assemble kits of parts, and stuff like this is missing. And I didn't think about them earlier because they're not long prints. They're just prints. Like, how much was this? This was 4 hours for one whole WinchBot's worth of these, so not that bad compared to a lot of the stuff I've been printing. The biggest part so far are those shells. Each half was about a 24-hour print. So that's pretty big, but you know, if you don't have a printer that's that big or that much time to spend with a printer that big, then they're totally optional. The robot works without the shell. There's just nowhere to mount the LEDs. You could certainly mount them anywhere you want. And there's less protection for curious cat fingers. But if you live in a place without curious cat fingers, or if you just are really mean, then you don't need to build a shell. This printer, this yellow stuff, is PEI, which I'm forgetting what it stands for. I think it's like polyetheriumide or something like that, but I'm not a chemist, and so that probably sounds terrible to any actual chemists. But it's some kind of polymer that I don't know exactly what property of it does this, but when it's especially when it's warm, but even at room temperature, it actually sticks to PLA reasonably well. but then after it cools, or if you apply just a little bit of pressure, you can get it to come loose really easily. And the only real maintenance that it needs is to be kept really clean. So I usually wipe it down with, it's funny, like pure isopropanol, like 99% or whatever, is actually not good for this. You want 70%. So I have some diluted isopropanol here that I clean it down with before every single print. And then here I'm always just fussing with things while I'm waiting for the printer to preheat so I can check the height. I should really upgrade this printer with automatic Z leveling one of these days. I still do it manually, and it's kind of annoying. This printer has some pretty nice pieces on it though, like the linear slides are really nice, and it's just like a really nice combination of size and accuracy. But it has a lot of the problems you usually get from FDM printers with things needing to be, like, I've had to replace the ribbon cables that carry power to the hot end several times. Those are pretty much a consumable part. Cleaning the hot end, a couple of hot end replacements. Well, not like hot end replacements, but like, there's a replaceable part on this printer, which is just the heating cartridge, the thermocouple, and the actual nozzle, but not the cooling part of the hot end or any of that. And I've had to replace that a couple of times. I use this printer a lot. This looks like it's starting just fine. Alright, well, I've got a lot of prints to clean up, and I will do those probably off stream unless people really like the sound of scraping plastic. But yeah, let me know what you're into, because I've got programming to do, I've got more mechanical stuff to do. You know, a lot of work on this project, but also a couple of other projects that are interesting and that I should stop procrastinating. So, you know. And as always, I super appreciate everyone hanging out and making stuff together. It's always nice to do this together and to have a little community around it. And I'll keep folks updated on the cat situation. I don't know exactly how long the surgery is going to take, but I imagine they'll call me in some hours and give me an update, and that he's going to, I mean, he's definitely going to have like a kind of hospitalization there to keep an eye on him afterwards, but I don't know how long that's going to take. So if you're curious about the kitty, I will be updating folks on Twitter along with all my usual shit posting. So if you don't want any of that and you just want to find out about these streams, then you can check out my @scanlime live on Twitter. That just announces the streams. And then you can always follow on directly on Twitch. I'm scanlime there. Or on YouTube, you can just search for Micah Scott or scanlime and you'll find my stuff there. So, well, thanks so much for stopping by. Thanks for hanging out, and as always, thanks to all my Patreon supporters and the folks who keep this going, and I will try to keep doing right by all of you. Oh, I just noticed in the chat that Ear was asking me about the Twitch stream that I mentioned. Yeah, let me show you. I actually had a keyboard here, if I just clear off all the stuff on my desk. Are they still unhappy? Kinda. Oh no, that's Bach. Cool. Hedberg. Yeah, so I recommend this channel. Hedberg is great. She does great reverse engineering, and she's been working on some underclocking and kind of intercepting data buses on the Nintendo Switch recently. It's been fun to hang out with. So yeah, I recommend that. Oh, and thanks for all the best wishes to the kitty. Yeah, I'll keep folks up to date on how he's doing, but yeah, everybody's wishing him a speedy recovery, and I'm just gonna be so glad to have him actually recovering instead of like the past few days. It's like he's, his body has been doing the best to like get his bones all healed up, and now the surgeon is just like, oh, nope, so much for that, cut, restick. And then it's just going to take more weeks of healing, and so it'll be nice to actually be on that road to recovery finally. But I just feel so bad for the little guy. Like, it's just a lot to go through. Oh, and he here says it turns out that GitHub ended up blacklisting their own CSS with their new core security policy they set. That's funny. All right, well, thanks so much for joining me. Ending this short stream, but I will catch you next time. Happy hacking, folks.